All right, so let's now turn to trig. You will have to be able to perform this procedure with trig functions as well. And with trig, there is a slew of memorization that comes first. So first thing you need to know about trig is you need to know how sine, cosine, tangent, all your trig functions are defined in terms of a triangle. A right triangle with some included angle theta. This triangle will have a y value, an x value, and a hypotenuse I will use r for. From this triangle, we see sine of theta is defined to be the y value over the hypotenuse. Cosine of theta is defined as the x value over the hypotenuse. Tangent of theta is y over x, and there will be three reciprocal identities. The only two triangles your professor will expect you to know are the 30, 60, 90, 45, 45, 90 triangles, which are there's your 30, 60, 90. And your 45, 45, 90. And notice I'm using radians, not degrees. Calculus actually does not work well with degrees, so make sure you use radians. All right. All right, so trig function. All right, where is this defined? Where is it positive? Where is it negative? Where is it zero? And we're going to restrict our search for solutions between 0 and 2 pi. All right, so the domain of sine and cosine is all real numbers. You can see that from their graph. The sine function and the cosine function. So sine and cosine have domain of all real numbers. So we see that our function has a domain of all real numbers. Your professor may accept 0 to 2 pi since that's the only area that we're looking at. I'm just going to write it as negative infinity. All right, so now we know the domain. We can set the equation to 0. And try to solve it. There is no fail-safe method that's going to solve every trig equation out there. It's not like the quadratic equation where the quadratic formula is guaranteed to work. We don't have anything that powerful with trig. There are a few good guiding principles though. One of which is that if you can get your trig equation all down to the same trig function, all sines, all cosines, or all tangents, a lot of times that'll make it easier to solve. So what I'm going to do is I'm going to divide both sides by cosine, and that would produce a trig function with only tangent in it. So divide this by cosine. Sine over cosine is tangent. Divide this by cosine. Solve for tangent. So we get tangent is 1 over the square root of 3. Now you need to be able to find two solutions to this in the unit circle, and the calculator is going to give you one solution and it will be a nasty decimal and your professors don't want that. So what I do is I draw triangles. What we see tangent is a y value divided by an x value. So in the xy plane, I will draw a triangle with a y value of 1, x value of root 3. Y value of 1, x value of root 3. Pythagoras gives us the hypotenuse. There's always going to be two solutions, so the other way we can think about 1 over square root of 3 is a negative 1 over a negative square root of 3. Drawing a triangle for this, remembering that tangent is a y value divided by an x value, I will draw a triangle with a y value of negative 1 and an x value of negative root 3. Again, the hypotenuse is 2. This should fit one of your two special triangles, and we see it fits the 30, 60, 90. And what we care about these reference angles. And what we see the reference angles are, they're the angles opposite of the side of magnitude 1. So we go over here and we find the side of magnitude 1, and we see the angle opposite is pi over 6. So each reference angle, pi over 6. Okay, so we have two solutions. One solution would be from here to here, that would just be an angle of pi over 6. If we were to start here and travel around this far, we will have traveled around a total of pi radians. Then we'd have to keep going. So this would produce an angle of pi plus pi over 6, 7 pi over 6. So these are the roots. So placing the roots on a number line, remember we're restricting our search from 0 to 2 pi, and we have a root at pi over 6 and 7 pi over 6. All right. Pick something between 0 and pi over 6. I choose 0. We plug 0 into this. We're going to get sine of 0. Sine of 0 is 0. We'll get cosine of 0. Cosine of 0 is positive 1, so we'll get 0 minus 1. We get a negative value. Between pi over 6 and 7 pi over 6 lives pi. So let's plug pi in. Sine of pi is 0. Cosine of pi we see to be negative 1. So what we'll get is 0 minus a negative 1 minus a negative becomes positive. So our function is greater than 0. Between 7 pi over 6 and 2 pi, I'm just going to choose 2 pi. Plug in 2 pi. Sine of 2 pi is 0. Cosine of 2 pi is 1, so we'll get 0 minus 1 or a negative value. So our function is again less than 0. So we can say that f is less than 0 from 0 to pi over 6 and from 7 pi over 6 to 2 pi. And we can say that f is greater than 0 in the middle.